So in your previous class, we have discussed about initial configuration of router, like how to configure a brand new router for first time, like by using console cable and emulation softwares like PuTTY and Minicom softwares. And Cisco routers, internal components and external components also were discussed. All right. Routers will work with iOS, Internet Network Operating System, and iOS versions and iOS modes we discussed clearly, like a user mode and its symbol, privilege mode, global configuration mode. Under global configuration modes, interface mode, line mode, router mode. So all the modes we clearly discussed. The task, the basic configurations, how to assign host name to router, how to assign IP address to LAN interface. By default, LAN port is a shutdown, and how to activate it by using no shutdown commands, and how to secure router console port by setting a passwords, which is console port password. After login to router, like user mode for junior engineers, like how to control junior administrators to the privilege modes by setting a passwords. Like user to privilege mode, we have a two type of passwords, which is enable password and enable secret. Like what is the differences between enable password and enable secret we have seen. Enable password is in the normal text, plain text. Enable secret is encrypted text. And later on, how to create virtual sessions in router, like how to enable telnet functionality by creating VTY passwords also we have seen. So I hope everyone have done your practicals. So have you faced any problems? Any doubts you have regarding configuration of router? Yes, please. Any doubts?
So from the PC, so when I ping that, there is a 100% data loss
From PC to?
router after pinging the default gateway.
So router IP address, I mean default gateway IP address and your PC IP address should be in the same network.
It's the same network, and I try to ping that is showing request timeout.
4 packets is dropped.
Only when I ping from PC4 command prompt,
Yeah.
it's showing it request timeout.
Okay. From other PC?
Uh, Same, both are same showing.
So what is the connectivity you have connected? Router to
PC4.
directly or switch? Router to switch?
In between switches there.
Yeah, switch to PC4. Okay.
Yeah.
For router, which port you connected?
Fast Ethernet 0.1, 0 by 1,
0 by 1.
0 by 0.
Okay, 0/0.
Yeah.
So what is the IP address you have assigned here for 0/0?
1.1, 1.1,
192.168.1.1.
1.1. Yeah.
Have you given no shutdown command here for fast
Yeah.
Ethernet?
You given. It's shown. Do I have got notification? Both are start up things
Upstate.
upstate.
Okay. So what is the PC IP you have assigned?
1.2.
Then it should
1.
be communicate.
Yeah, but I have to check again after.
I think maybe you have assigned IP address to fast Ethernet 0/1 and cable is connected to 0/0.
I will cross check, sir, once again.
Yeah, you can check it out. Okay.
Okay.
All right. Any more doubts? Remaining all are, have you done your practical?
In the interface command follow,
Yeah.
when we are selecting, we'll have to select the specific interface and it is being configured for only that specific interface, is it? Or it is
Yeah.
going to configure for the entire device?
No, only the specific interface only.
So we should very clearly specify that particular
Particular
port
interface. Yes.
interface, okay.
Yeah.
But that is not the case with line and router.
No.
Thank you.
Yeah. All right. So today let me continue with WAN technologies. So example here we have three routers. Let it consider the first is your branch office one network. This is like your PC is to switch and switch to router. This is branch office one. The right side branch office two. This is one setup. The middle one, let's say, is your head office. So three offices in geographically different locations. So here I have used one in Chennai, one in Hyderabad, one in Bangalore, like different locations. Like how to connect these devices, how to connect these routers between Chennai office to Hyderabad office and Hyderabad office to Bangalore office. Like how to connect this, what type of technology we require,
WAN technology.
WAN technology. So why we need to connect from branch one to head office? Like why we need to connect head office to branch office to? Why this connectivity is required?
Communication in between those three.
So we need to enable network access, means communication. So means these LAN users and LAN users should communicate, network access, right? So generally network access in two types of network access. So what type of network access means your branch one and head office connectivity we can connect via a normal public network. Whatever nowadays we are using for your home internet, which is a broadband internet. So via that type of connectivity we can connect. This is one type of technology, which is normal broadband connectivity. Or one is a enterprise network access. So we are using a dedicated line, a separate line for your offices only, not to the public network. So in WAN technologies, we have a type of network access is two. One is enterprise access, internet access. So internet access is generally or whatever you're using for your homes or offices, this is for internet access. So internet access means like all public servers are connected. Like you can access Google server, you can access Gmail server, Facebook server, YouTube, like all public domain. This is internet access. Enterprise access means only your office's traffic can be forwarded. Your branch office one traffic can move to head office traffic can move to branch office. These are basic two types of network access, enterprise and internet. In enterprise, again, you have different type of technologies. One is dedicated technology, switched technologies, and VPN technologies. In dedicated lines, we have laser lines, circuit switched in, packet switched, GRE VPN, IPsec VPN, DM VPN, different type of WAN VPN technologies there. In circuit switch and packet switch, technology is PSDN lines, ISDN lines, frame relay, MPLS. These are all different type of technologies we have actually. In internet again, dedicated internet, switched internet, broadband. In modern network, at present, what type of technology we are using for our IT companies? Laser line, VPN, MPLS. So these technologies in modern network we are making use nowadays. Like in our CCNA training program, we will discuss about VPN and laser line. MPLS in CCNP level classes we'll discuss. Like PSDN lines, ISDN lines, these all are outdated technologies. In frame relay is being modified into MPLS. Okay. So most of the IT companies present laser lines, VPN, and MPLS. So today we'll discuss about laser line, and in Cisco Security class we'll discuss about VPN. Right? There are types of WAN technologies. Types of WAN technologies we have discussed. Let me clearly explain what was the differences between laser line and normal broadband. This is your network, end user devices. Here all end user devices are connected to switch with RJ45 cable and switch to router. So you're asking for internet. You contact a service provider. So where your network is located, say your network is located in Hyderabad, Namirpet, road number 5. Hyderabad, Amirpet, road number 5, I need internet. I contact a service provider. Say service provider is in a Banjara Hills. The service provider will give directly a link from Banjara Hills to our office router, our home router? No. So what service provider will do? They will check, okay, in Amirpet road number 5, how many customers is there? So you only is not the customer, right? There will be number of customers. Then what ISP will do in road number 5, they will keep one switch, ISP. Says ISP device. From the device, they'll connect it to customers. Like let's say customer 1, they require internet. From the same switch, they'll give one cable. I am a customer 2, like customer 3, customer 4, customer 5, like all customers. From this ISP device, they will give the connectivities, the copper wire, RJ45 cables. From ISP switch to Banjar Hills office, they used to maintain optical fiber cable. Can be 5 kilometers and 10 kilometers, whatever. They used to maintain what? Optical fiber cable. This is the connectivity. Now, what type of technology are you using here? Broadband technology or laser line technology? What type of technology are you using? Then what is the differences between your normal broadband and laser line technologies? See, if you're using normal broadband, your regular internet access, ISP is telling is that your customer 2, your internet speed is 16 Mbps is telling. So if he's saying 16 Mbps, can we get always 16 Mbps for your network? Generally, for your homes also, if you have a 40 Mbps or 50 Mbps link speed, did you get always 40 Mbps link? No. Up to 40 Mbps we can get, right? Speed can be any, like 10 Mbps, 20 Mbps, 30 Mbps also. Up to 40 Mbps is telling that. So means there is no fixed bandwidth. No fixed bandwidth. Next point is customer 1 network is connected to ISP switch. Customer 2 network is connected to ISP switch. Customer 3 network is also connected to same switch, right? Let's consider customer 3 is a hacker. Now what customer 3 will do? Like customer 1 traffic is going to via ISP switch. Customer 2 traffic also. Now customer 3 is also part of the same switch, same device, right? Now all the customer 1, customer 2 traffic, he can be captured, he can be monitored what they are forwarding the traffic actually. What type of websites and what is the passwords, all those things you can be captured. because of all customers in the part of the same device. So here lack of security, like means less secure. Second point, right? Less secure. Next point is, say your optical fiber, your OFC cable is down. In your area, optical fiber is down. Like you get a complaint to service provider, we are not able to get internet access. Then what service provider will do? Dear customer, you may experience service internet interruption due to the fiber cut in your area. We are working on resolving the same. So it should be take some 2 hours or 5 hours or 10 hours or 24 hours, they can say time, right? Okay, you have waited a 24 hours. After 24 hours also, it has been not resolved. Again, you complaint. What ISP will do again is still we are working on the same. So soonly you can accept, like we'll tell, right? So maybe a downtime will be, it can be 4 hours, it can be 24 hours, it can be 2 days also. Can we demand to service provider, no, I need immediately, I need internet access, I'm paying monthly. And can you demand to ISP? No, we cannot demand, right? So means
No
there
reliability.
will be more,
No, it's not reliable.
yeah, more downtime. Downtime is more, can be 4 hours, that can be 24 hours. So these are all the problems which generally we face in normal broadband access. No fixed bandwidth, less secure. Secured, okay, because of we are using applications, good applications we are using, but connectivity is not secure and more downtime. Then what is the advantage here? It is very cheaper cost, less cost we can
Cost,
get. Yes, very
cost
cheaper
effective.
cost we can get internet access. If we say home network, okay, home network means so now our transactions very simple transaction will be there. Our usage also very simple usage for home. So we don't require, we don't need to be fixed bandwidth. So whatever the bandwidth you are getting is very sufficient, right? So normally your normal bank transactions, normally your social medias where you visit, and maybe you're browsing the internet. That's it, right? So anyhow, we are not sharing any sensitive data or any content like a commercial, right? So this is very good enough. If it's a downtime for 24 hours, also no problem. Alternately, we are using the mobile data, right? But what if it is a office networks? So what if it's a commercial network? Then I'm asking to service provider, no, I don't want this type of links because of this is my office network. Like this branch office want to connect it to another branch office. So I need a dedicated line, a separate line. Now what service provider is doing is, okay, for customer 2 is asking a dedicated line, he will provide a separate link from ISP to customer. So via this link, customer 1 traffic is not moving on, customer 3 is not moving on. Like so only customer 2 traffic will be forwarded. No other customer's traffic is involved here. So via this link only our customers, like our traffic only, a branch office 1 traffic to forwarding to branch office 2. So means here the first point is what here? More secured. Network is first thing is what? Secured, more secured. And if link is a 10 Mbps link, ISP is telling is that your link is what? 10 Mbps. Then always we can get 10 Mbps. Every minute, like every second can get what? 10 Mbps. So your bandwidth is fixed bandwidth. It is not like a up to 10 Mbps, means 1 Mbps, 2 Mbps, or 5 Mbps. It's not like that actually. If ISP link is 10 Mbps link, then always you can get 10 Mbps. Bandwidth is fixed bandwidth, more secure. And ISP will promise on the leasing lines is less than 1% downtime. If any link is being down, even as a customer, we need to be complaint. Complaint is not required because of there is a dedicated team for service providers for leasing lines. If any link is down, that engineers is be monitoring within a less time, they'll be resolve your problem actually. So ISP Stellage is promising is that laser lines are what? Less than 1% downtime. 1% downtime is what? Mostly no downtime. So this is a major differences between laser line and broadband services. In laser line, bandwidth is fixed. Here, no fixed bandwidth. It's more secure, lack of secure, no downtime, more downtime, but laser line is a very high expensive, high cost, high price. Then where we use broadband for your home networks, generally you can use for broadband. For commercial networks like IT companies and government sectors and private sectors like banking sectors, they use what? Laser lines. It's clear? Okay. So type of WAN technology, laser line, and now WAN topology stage we discuss. WAN topologies. Says my commercial network. Let's consider head office, branch 1, branch 2, branch 3. See, this is not a home network size. It's offices like head office to branch 1, like commercial network. Now to connect between head office to branch 1, which type of technology do you recommend? What type of connectivity? Broadband connectivity or laser line? Which technology do you recommend? Laser line. Yes. So I'm taking a laser line from head office to branch office 1. One laser line from head office to branch 1 via serial ports. Serial 0 and serial 1. Now branch 1 head office can start doing communication securely. Bandwidth is fixed. No downtime. Now from head office again, I'm taking one more laser line to branch 2. Towards my branch 2. From serial port 1. Like one more laser line from head office to branch 3. Serial port 2. So here, branch 1 is connected to head office. Branch 2 is connected to head office. Branch 3 is connected to head office. Like number of branches are connected to head office, one head office. So if we design like this type of topologies we call hub and spoke topology. Or we can call star topology. So what is the good thing in hub and spoke topology? Like if we design like this, also what is the advantage here means less number of connections. Like to connect 4 offices, we have used here only 3 laser lines. So less number of connections. Implementation is very simple. Maintenance is very easy. Easy to deploy. Right? This is the advantage of hub and spoke topology. But problem is, know how exactly branch office 1 LAN users and branch office 2 LAN users, how they can extend the data. Do you have any direct link from branch 1 to branch 2? No, no direct link, right? Then all branch 1 traffic will come to head office and head office forward to branch 2. So here all spokes like 1, 2, 3, branch 1, branch 2, branch 3 are spokes, head office hub and spoke. So means all spokes can talk each other via head office only, right? Now what if branch 1 head office is down? If link between branch 1 head office is down, then branch 1 can communicate to head office? No. Branch 1 to 2? No. Branch 1 to 3? No communication. If any one link is down, no communication with from branch offices. Single point of failure. I mean, no backup link here. No redundancy. So this is the problem in hub and spoke topology. But what's the good thing here? Less number of connections. Implementation is very simple. Maintenance is simple. But problem is no redundancy, no backup. So to overcome this type of issue, so what we are doing is let we change our topology. I'm taking one more laser line from branch 1 to branch 2, branch 2 to branch 3, and branch 1 to branch 3. So each branch connect to each other branch. So this type of topology we call full mesh topology. So what's the good thing in full mesh topology? Between branch 1 to head office, if link is down, no problem. Why? Because branch 1 traffic will send to 2 to head office, they can communicate. So means redundancy is available. Not only single link, even branch 1 to branch 2 link is also down. Still, branch 1 forward the traffic to branch 3 to head office. So here, full redundancy, multiple backup links. Backup is available, full backup is there, right? So there's a good thing in full mesh topology. So which topology do you recommend to use in the real time? Hub and spoke topology or full mesh topology?
Full mesh.
Full mesh. Why?
The backup is there.
Redundancy is there, backup is there. Okay.
Backup.
The point is, compared to laser lines are what? High expensive, high price, right?
Expensive.
Means to connect 4 branches, how many laser lines are being used here? Laser line 1 between head office to branch 1, laser line 2, laser line 3, laser line 4, laser line 5, laser line 6. So 6 laser lines. Each laser line we need to pay for service provider. Very high expensive. And moreover, more number of connections. It's creating more complex. Maintenance issue will come. More complexity. Configurations issues. And high expensive. So this point also need to be think about it. You're just thinking is what? Backup is there. Okay, backup is there. But problem is what again? More number of connections, very high expensive, complexity, configurations issue, maintenance issue. These are also problems. So now tell me, which topology is the best? Hub and spoke topology or full mesh topology?
Based on the business risks, for a bank, full mesh topology is ideal. For
Okay.
low business, like a
Government
shops or
sector.
maybe for some restaurants which have branches around,
Okay.
they can go for the first one.
Okay. See, what is a drawback in hub and spoke topology?
No redundancy.
No backup.
No redundancy. Okay. See here, we are not making use the links is a broadband. If it's a broadband links, there is a more downtime. So already we have used what? Very no downtime links, more secure links, fixed bandwidth links. Laser line you're using, right? So laser line means less than 1% downtime. So only for 1% down, we require a backup. So only for 1% downtime, then why we require the multiple backups here? Do we need a backup or do we require a multiple backup?
Backup.
Backup is enough. We don't need a multiple backups, right? Because of already our links is good links because of you're using laser lines. So laser line means there is a less than 1% downtime. Only for 1%, we required only for temporary, alternately one backup link. But in full mesh topology is what? Multiple backup links is there. First link is down, yes, they can communicate. Second link is down, yes, they can communicate. So then why multiple backup links are required? It's creating very complex in your network, configurations issue, maintenance issue, very high expensive. So what we use in the real time means a combination of hub and spoke topology and full mesh topology, which is
Which table?
partial mesh topology. Backup is there, single backup link.
In between,
Redundancy is there. Yeah,
in between, we have to use only one backup.
one
By
backup
removing,
link.
only
Exactly.
by removing head and first branch and only
Anyone link you can remove it.
Okay.
Yeah. So these all are WAN topologies. WAN technology topologies. It's clear? Star or hub and spoke topology, easy to deploy, less number of connections. But the point is what? No backup. I mean, no redundancy. This is a diagram. Full mesh topology, all branches are interconnected. Full redundancy, but more connections. Complex configuration. So most commonly used what? Mix of star and full mesh topology. Single backup. Okay. So if you go for your companies as an engineer, you have to understand your office also which type of topology is designed. If your company is using hub and spoke or full mesh or partial mesh, that is also need to be understand actually. So how the lease lines is connected? I'm just drawing a one line here, head office to branch one. But what is line? Like what type of equipment is required? What type of cables are required? How service providers will give the lease line? What cables they used? So that connectivity will be discussed. WAN connectivity. For example, here you have one lease line connectivity, two offices. So this is Chennai office building, Hyderabad office building, two offices in different locations. Now between these offices, we required lease line connectivity. Now this office premises, end users are connected to switch and switch to router. This is normal connectivity, we know this, right? Now from Chennai router to Hyderabad router, we required lease line. So we decided to use lease line, right? Now we contact to service provider, ISPs, like who service providers is giving lease line connectivity, we contact to lease service providers. Then what service provider is doing is, router 2 we have to use V35 cable connected to modem, which is CSV modem. Router 2 modem with V35 cable. Channel service unit, data service unit modems. So this modem is going to do, what is the job of this modem is going to convert your copper, like electrical signals, like copper wire. So RJ11 signals to serial signals, like 60 pin, 26 pin signals. And copper wire to service provider. Like this is copper wire is providing by service provider. So it's pair of copper wire. So this copper wire other end is connected to ISP MUX multiplexer, like Chennai office multiplexer, Hyderabad office multiplexer. Like Chennai office MUX to Hyderabad office MUX. In between, they can use what? Fiber optic. So these MUX, optical fiber cable and copper wire, these all the things is being maintained by telco department engineers. So we need to be not maintenance actually here. So these things we are not required. So what is our job? Our job is only this range will to be take care. So this range we call CPE range, customer premises equipment. In the customer location, what equipment is a that only will be maintained. Like if any computers issue, as a network engineer, we need to be resolve the problem. If any problem in switches, yes, network team has to do that. If any router and routing protocols issues, we have to solve that. And if any modem issues. So these all are taken care by our team, network team. If everything is okay here in premises, like in customer location, if everything is okay, but still no communication, then we can make a complaint to service provider, and service provider will check any issues in the fiber cable, any issues in the marks, any issues in the copper wire. So these things are maintained by service provider. Anyhow, service provider is telling is that our premises there is less than 1% downtime. Okay, so this is a laser line connectivity. Router to modem, modem to mux, mux to mux by using optical fiber cable, same other end also. It's clear? See, what is bandwidth and what do you mean by speed? Bandwidth means what? Speed is what?
Is both are not same?
Okay,
Speed is kilowatts like that we can like.
yeah.
I think bandwidth also we can measure kpmh.
Like total availability of the link is bandwidth.
Mm-hmm.
Transfer capacity.
Yeah, capacity. Yes. Small example. Let's consider this your water pipe. The water pipe. So what is availability here? It's complete availability. Like from here to here, you can utilize it, right? So how much the pipe velocity, like complete availability, this we call as a bandwidth. It can be 2 inches, it can be, I'm talking about pipeline. It can be 4 inches, it can be 5 inches, it can be 10 inches pipe. This, what is total availability is what? Bandwidth. It can be 100 Mbps or 500 Mbps or 1000 Mbps. This is a bandwidth. And water flow, like how much water flowing, means that is the speed. What is the availability here and the flow of the water, that is the speed actually. So the water can utilize half of the pipe or full of the pipe, like whatever. So that is the speed actually. So to easily understand technical terms, is your home router. You're using Wi-Fi router, say D-Link router. You ask to service provider, ISP. Now from ISP, we'll get one ISP link, right? Cable, internet cable. So what type of cable you're using nowadays for internet? Normal home internet. RJ?
Fiber cable.
RJ45.
Okay.
Do you have the fiber cable at your home? ISPs will fiber. So you have seen this diagram. From ISP to nearby your area, road number 5. So nearby area to ISP, there is optical fiber cable. From nearby, from your area to your customer location, there is what? Copper wire. RJ45. It can be Cat5 or Cat6 cable. Let's say Cat6 cable, right?
Some of
So
the network
Cat6,
providers providing fiber cable up to our home.
Fiber optics only. Some
Fiber
internet.
optics,
see, that is what. If you require the more than 100 Mbps, then very high speed links, then you can use optical fiber cable also. If it's normally like a 15 Mbps, 40 Mbps links, we are getting copper wire only, RJ45 only.
Okay.
Yeah, in my home, using fiber optics only.
Fiber optics. Okay. Let's say fiber optics or cat cable. What is availability of the link? How much speed? Cat 6 cable, data transmission rate. Cat 6 it can support for what? 1000 Mbps, right? 1000 Mbps. So a cable supporting for 1000 Mbps means your traffic is reaching to internet with 1000 Mbps. Is it?
No,
No. So means the total availability of the cable is what?
1000 Mbps.
1000 Mbps. That is the
Mbps.
bandwidth of the link. This link is what bandwidth is 1000 Mbps. Then how much bandwidth you can utilize to send the traffic? 1000 Mbps or 500 Mbps or 10 Mbps. How much?
Up to 1000.
Up to 5.
Up to 1000 means you can send the traffic with 999 Mbps also?
Yes.
No. So how we can get 1000 Mbps internet link for your homes? You're paying very few less cost, right?
Okay, broadband, I mean.
ISP will decide something how much it want to allow to the link actually, no?
Okay.
So what ISP will do? Okay, you are using Cat6 cables or maybe you're using optical fiber cables, but how much bandwidth it is allowing, that is something decided by what?
ISP.
ISP router.
SPs.
So ISP router is a master and customer device is a slave. So that technically we call master is DCE device, means data communication equipment, and customer device slave is a DTE, data termination equipment. So master means the device which decide the bandwidth, that is a master device. So how much bandwidth is decided by ISP, that bandwidth will be accepted by slave. The device which accept that, it is a slave. Now what ISP will do based upon your customer plans, based upon your plan, like internet plans, they'll allow you for 100 Mbps or 40 Mbps. Let's say 40 Mbps your internet speed. So what ISP will do? So on some customer, your link now, your bandwidth is what? 40 Mbps based upon the plan. So that master has been decided, right? He's generating. So he's generating 40 Mbps. So that 40 Mbps link speed, your office, your home router will accept that. Now your router will understand, okay, this link bandwidth is now what? 40 Mbps. Even if it's a Cat6 cable also, now it is like not, it is not 1000 Mbps. Now what is the link speed now?
40.
40 Mbps. So if you want to use the more than 40 Mbps, then you can ask to service provider. So I want to change my plan. I don't want, it's not sufficient of 40 Mbps. Then what ISP will do? Okay, I'm changing your plan into 140 Mbps. Now ISP will generate it. Now what your slave will do? Okay, I'll accept you, and I'll forward to 140 Mbps. So still, if it's not sufficient, then what ISP will do? Like what a customer will ask to ISP? No, I need more than very high speed link. So this cable can support up to how much? 1000 Mbps.
1000 Mbps.
So a bandwidth something decided by service provider, the device a master, and which is accepting that bandwidth, that is a slave. So here we'll see device classification, DCE and DTE, data communication equipment, generate clocking, which is speed, master device. Example of DCE is CSC modem or service provider device. DTE, data termination equipment, accept clocking, is accepting clocking, which is slave. Example of DT is customer device, customer router.
What is generate clocking and accept clock?
Generate clocking means this is, he's generating 40 Mbps speed, that 40 Mbps is accepting, okay,
Oh, okay.
that is generating, is accepting. clocking is nothing but bandwidth is generating.
Balu, here that ISP is deciding the bandwidth. If the different customers has the different speed requirements, how it will be handled?
This is on customer 1 link. Customer
Okay.
2 link with another link. So another link also he will generate. This is also again master. So with another interface, he will generate 80 Mbps link. Another customer, he will generate 20 Mbps here. Another customer, like he will generate a 40 Mbps here, like this.
I mean, if from the ISP, if there is a switch, from there the different connections are going to the customer. It can also be handled to this master. I mean the speed.
Yes, he will configure the switch ports, how much speed you have to allow,
Okay.
like that.
Small one dot is there.
Yeah, please.
In home routers, default they have two types of bands, means 2.4 and 5 GHz.
Yeah.
Even though it's suppose 40 Mbps, when 2.4 gets slower and 5 GHz gets speed, then what is the difference between 2.4 and 5?
That is a wireless.
Okay.
Means, customer means this is your mobile phone. Mobile phone to your Wi-Fi router speed is a 2.4 GHz or 5 GHz.
Yeah.
Not from your router to ISP.
Okay.
2.4 is only your local speed. Okay, like you are in a 50 meters distance, or maybe you're in a 5 meters distance, or you're in a 100 meter distance. It can be support, which is 5 gigahertz. So gigahertz is what frequencies. So frequencies where we can support in LAN only, in local only. Means you are in a kitchen room and your device in hall. It can be support for 2.4 gigahertz and 5 gigahertz. But internet speed is what? From your router to ISP side, that is the bandwidth.
Okay.
Yeah.
Have a one doubt.
Yes.
It clock rate and generate clock rate is the same.
Generate means he's assigning. He's defining some clock rate. Means he's defining some bandwidth.
My question is, it's the same or different?
Same.
I mean, if it is 40 Mbps, still we get the 40 Mbps, or due to loss we'll get something less. That is what his question, I think.
No, he's generating 40 Mbps, right?
Yeah, from as I mean here the at the receiving end, still we get the 40 Mbps or something less.
No, up to 40 Mbps.
Okay, up to 40 Mbps means it might be less also.
Yes.
Okay.
But who is deciding the 40 Mbps?
ISP.
That is a master.
Yeah.
A 40 Mbps is nothing but clock rate.
Yes. Generating.
Yeah. Stay, Madhu?
Yeah.
Okay. So next point is, so this is how ISP router to customer router, and if routers on the different locations, they use optical fiber cable, MUX, copper wire, CSC DAC modem. These are all the equipment. Okay. Now what if two routers distance between short? Between the two router distance is short. Like in your lab type of scenarios, router 1 and router 2. In your lab, like there are number of routers, like one router to another router you want to connect with WAN link.
One
Then
will be the master, the other will be the slave.
so when routers between the distance is short, now do you require MUX here?
No.
No. Optical fiber cable? No. All are CSC DAC modems all are replaced with special cable. One cable with R1 to R2 back-to-back cable you have connected. R1 S0, R2 S1 like connected. Okay. Now which one is a master, which one is a slave here? I mean, which interface will generate the bandwidth and we shall accept it.
Router 1 is a master.
We should
Based on the
configure it. No.
frequency
Based on
of
the
the
requirements,
routers
we should configure the router
and
as master
frequency
and
of the
the slave.
router.
See, this is serial back-to-back cable. Is the cable. When we use this cable, when the distance between two routers is short, a special V35 back-to-back cable is used to replace copper wire, modems, and mux. So if we use this cable, then which is a master and which is slave means that cable is predefined. The cable itself is predefined. See, one end is a DCE is predefined actually, you know. In other end is what? DTE
DT.
is already defined. And where we are connecting, it depends upon you. So DC end, you are connected on router 1 S1. Here you have connected. And DT end, you are connected to router 2 on S0. Now, which is a master, which is a slave?
DC is master, DC is slave, DT is slave. Router 1 is master.
Router 1 is a master. Router 2?
No.
Slave.
No. Right? 90% is right, but 10%. Because router 1 is a master, but the point is here, in router 1, how many serial ports is there? Serial 1 and serial 0, 2 ports is
Serial.
there. So you can, can you say router 1 is a master? No.
Serial 1 is the master, yes. The port is
Exactly,
the master.
exactly,
Yeah.
exactly. That is the important point actually. Router 1 S1 is a master. Router 2 S0 is a
0 is a DT.
slave. DT, yes. So simply we cannot say router 1 is a master, router 2 is a slave. Because of router 1, there will be number of ports. There will be 10 serial ports, 20 serial ports. So then how can say router 1, all ports are DC? No, right? The port is where you are connected the cable.
But we should.
Yeah.
But this should be configured, right?
Yeah, if we connected DC cable on R1
DC.
S1, on R1 S1 we need to be generate a clock. I mean, we need to configure a clock.
Yeah,
We
we
should
need to
configure it.
configure.
Yes, we need to configure that. But we cannot configure bandwidth on R2 S0. We cannot generate it. We cannot configure. Why? R2 S0 is what?
Slave.
Slave. It's a DTE. So where we can generate, where we can configure? On
Router 1
DC and you
S1.
can configure. Router 1 S1.
S1.
Yes. So in this case, let's consider router 1 S0 is DTE, router 2 S1 is DCE. So which is a master, which is a slave?
S1 is the master.
R2,
S0 is the master.
R2 S1 is a master, right? R1 S0 is a
Slave.
slave. So actually this serial cable, back-to-back serial cable, maximum it can support 12 Mbps speed. But on master device, I mean on master port, on serial 1 port, we can decide, we can generate clocking how much we can set the speed. So it can support from where like 2 Mbps to 12 Mbps, minimum and maximum. Minimum 2 Mbps and maximum is what? 1 Mbps, not only 2 Mbps, minimum 1 Mbps to, and it can support for what? Not only 1 Mbps, 0.2 Mbps to like complete 12 Mbps can support. Minimum and maximum. So something we can define, we can generate the clocking and where on R2S1. So I have configured 1.54, 1.5 Mbps. So actually can support for what 12 Mbps, but I have configured 1.5 Mbps. So means where it bandwidth is generated, master bandwidth is generated, it'll update to R1. Hello R1, have generate some bandwidth, and what R1 will do, I mean R1 S0 will do, will accept it, and R1 S0 will adjust. Speed is 1.5 Mbps. Now the link is now can support 1.5 Mbps. They can share the data. Both can share. Exchanging is both are okay. Okay. Like this, master and slave can decide it. All right. This back-to-back cable will is only in when the router is in the short distance. In the real time, ISPs will configure the bandwidth. So ISP is the master. So this is a scenario only for your router's shortest distance only. Okay.
Based on scenario, we are defining this is DCE and DTE, or that is
Based upon the
predefined.
cable. Cable is predefined.
Okay.
Balu, now this type of connectivity and we are using right now also because 12 Mbps is very less na speed.
That is what this type of connectivity will use in internally, like within your office, you have a 2 routers to connect. This cable have to use between, if the distance between 2 routers is short. In your office, you have a 10 routers. Router 1 to router 2, back to back, if you want to connect, then you can use this cable. Not from your router 1 to router 2, I mean branch 1 to branch 2. Internally.
Okay, but internally is also 12 Mbps is very less speed, na?
Internally, 12 Mbps is a fixed speed. It's very good enough actually. Internally, 12 Mbps is good. See, this is
Balu, can you
availability
ask
is there.
Shiva to
Yeah,
Balu, can you ask
availability.
Shiva to mute his mic?
Okay, Shiva. See, of course, we can connect router 1 to router 2 back-to-back cable by using serial port also. Or router 1 to router 2, we can connect from fast Ethernet 0/1. Because of fast Ethernet 0/0, anyhow we are connected to LAN, right? So router 1 to router 2, fast Ethernet 0/1 also, like LAN port to LAN port also you can connect by using a copper Cat6 cable, Cat5 cable. Then the link will be support 100 Mbps. It's 12 Mbps. So this also is possible. So master and slave is a matter of only for serial type of connectivity. When you use a normal LAN port, no master, no slave. A link will be support 100 Mbps. Okay. So finally, let me make a clear diagram. Say R1, R2, two routers. R1 to R2 is a line connectivity from serial ports. Like between we have the MUX, optical fiber cable, everything is there. Okay. Serial 0, serial 1. Here also can connect serial 0. My example, serial 1 I'm using. LAN port, when fast Ethernet port, connected to your local network. R2 LAN port also connected to local network. So yesterday we have already discussed how to assign IP address to LAN port. 192.168.1.1. No shutdown and link will be up. In router 2 also, say something 10.0.0.1. No shutdown and link will be up. Now what about your WAN ports? So serial ports, you have one condition here. Condition is IP address of R1 S0, R2 S1. Like both are point-to-point connected, right? So means point-to-point connected interfaces both should be in same network address. IP address between R1 S0, R2 S1, both should be in what? Same network. Like 172.16.0.1 I have assigned here for R1 serial 0. For R2 S1 should be in the same network address, like 172.16.0.2. Is a condition. You can use any IP address, like any network, class A, class B, class C, any network. But condition is what both should be in same network addresses. Okay. All right. So how we have configured IP address to LAN port? Same commands. Interface fast Ethernet 0/0, IP space address space IP address subnet mask no shutdown. Similarly, interface serial 0/0 or serial 0 IP space address space 172.16 subnet mask no shutdown, like this. Now traffic is generated from R1. Traffic is being generated. Will come to fast Ethernet, and fast Ethernet status is what? Upstate. And fast Ethernet will send the traffic to which one? S0. What we call this process? Sending IP traffic from fast Ethernet to serial. What we call this process? Sending IP traffic from one interface to another interface. What we call this process, guys? Packet switching. Right? Okay. So after packet switching, now what serial port will do? Your data traffic, packet forwarding, right? So before forwarding data traffic, your serial port, your WAN port is adding headers. Is adding what? Headers to the data. Do you remember what we call this process, adding headers to data?
Encapsulation.
Exactly, encapsulation, right? So encapsulation is a process of adding. Encapsulation is a process of adding a new header or trailer to the data. For what purpose? Header and trailer contains information which is needed for proper transportation of data. Your data has to be in proper transportation. For that, headers and trailers will be useful. But here we have WAN encapsulation. WAN interface encapsulation method. So WAN interface encapsulation protocols are two different type of protocols. One is point-to-point protocol, triple P, point-to-point protocol, triple P, and another is high-level data link control, high-level data link control, HDLC protocol. Triple P, point-to-point protocol and HDLC protocol. So where we use HDLC and where we use point-to-point protocol is, like if R1 router is a Cisco router, if R2 is also Cisco router, if both are same vendor, like both are same Cisco routers. So HDLC is a Cisco proprietary protocol. Like every Cisco router, serial ports, SDLC is enabled already. Even we know to be configure. We have connected to connectivity. When serial port data will come, what serial port will do if it's a Cisco router? On S0, SDLC is enabled already. Inbuilt is there. Is adding SDLC headers and data SDLC headers is moving. So SDLC protocol will work in only Cisco routers. Now what if you are using R1 is a Cisco router, R2 is a non-Cisco, like in other vendor, Juniper, D-Link, like some other vendors you're using in a one other end. One side is Cisco router. So can we configure SDLC in other vendors? No. So we required one open source protocol. So that is point-to-point protocol is a open standard protocol. Okay. So first difference between SDLC and point-to-point protocol is SDLC is a Cisco protocol. Point-to-point protocol is open standard. All right. One more point is if it is a SDLC protocol, data plus SDLC protocol. Both are forwarding to router 2. Router 1, router 2, both are connected via service provider network. It can be lease line or it can be broadband, whatever, service provider network, right? Now, via service provider network, in the middle, someone can create some fake network. Let's say hacker is created some fake network. What hacker is doing is he's creating router 1. I am your branch office 1. Fake network is created. Branch office 1 and middle. Now what hacker is doing is he will initiate the data traffic to router 2. Hello router 2. I am your branch 1. You give reply to me. Now what router 2 will do? Instead of giving reply to router 1 of your branch, router 2 will give reply to fake office, like fake network, hacker network. Then all the traffic will come to router 2. Router 1 hacker can monitor that. So here router 2 does not understand where the traffic is coming. Traffic is coming from the fake network or traffic is coming from the genuine network. Router 2 don't know. Problem. So your router 1 and router 2 should be authenticated here. When data is exchanging, our data should be authenticated. So for that authentication, point-to-point protocol support. Your WAN encapsulation authentication can support for by point-to-point protocol. Point-to-point protocol support authentication. SDLC, no supports for authentication. So which protocol do you recommend to use in the real time? Point-to-point protocol or SDLC? Even if it's both are Cisco routers, like R1 is Cisco, R2 is also Cisco, both are Cisco, which protocol do you recommend?
HDLC.
So
Point to point.
SDLC will not support for authentication now. So better to go for point-to-point. So point-to-point protocol is open standard. It can work in Cisco also, it can work in non-Cisco also. Okay. But point is here. Let's consider router 2 is a non-Cisco router. It is non-Cisco. Router 1 is Cisco. In router 1, I have configured SDLC protocol. And router 2, can you configure SDLC? No. Because of router 2 is what? Non-Cisco. Then I have enabled what? Triple P, point-to-point protocol. See, in one end is a SDLC, other end is a point-to-point protocol. If your protocol is mismatched, your encapsulation is mismatched, your link will not come up, your link will go downstate. So both ends should be maintained the same protocol. You know why? Point-to-point protocol supports for what? Authentication, right? Now SDLC without authentication traffic is coming, then what protocol will do point-to-point protocol? So I don't trust you because you are not authenticated protocol. So I am authenticated, I am secure here. So but your traffic is coming from without authentication, I don't trust you. So I'm making my link is down. If link is down, no communication. So one side, if we use point-to-point protocol, other side also have to use what? Point-to-point protocol. Okay. Let's say example, both are Cisco vendors, both are Cisco. One side if we use SDLC, other side also have to use what? SDLC protocol. So this protocol should be matched. Encapsulation should be matched both sides. No, one side I use SDLC, other side let me see point to point will not work. The link will be down. It's clear? So there are different type of WAN encapsulations, point to point protocol and SDLC. Open standard protocol supports authentication, supports compression also, data compression. SDLC, high level data link control, vendor proprietary protocol, no support for authentication, no support for compression. Okay. So now we discussed about type of WAN technologies, type of WAN topologies, WAN connectivity, DCE, DT interfaces, point-to-point protocol, HDLC protocol. Let me continue with WAN interface configuration. Like how to configure WAN interfaces along with WAN interface troubleshoot. Finally, link verifications, status, WAN link status. Let me try to cover up these all the points now. WAN interface configuration, troubleshooting, and verification. Okay. So identify serial interface, either DC or DT. Like how we can identify which is the DC and DT means by using command. In privileged mode, you can use this command, show controllers, serial and serial number, and we can get it is a DCE or it is a DT information. If it's a DCE, you can generate the clock. If it's a DTE, other side will generate, you can accept it. It can accept it. WAN interface configuration commands, interface, serial, and number, IP address, subnet mask, no shutdown, clock rate, how much bandwidth you want to set, you can generate here, encapsulation. So clock rate command is only if it is a DCE. Then you can use this command. If it's a DTE, not required. It will design one clear diagram with 3 routers. We open the packet tracer software. To A11, R1, R2, R3, 3 routers. So we know the connectivities, switches, and end user devices. It's a 1, 2, 3, 1, 2, 3, 1, 2, 3. The connectivities, I'm using automatic cable, router to switch, and switch to PCs. Okay. Now router to router, which cable have to use? No connections here showing serial DCE cable. Serial DCE showing the clock symbol. Have you seen this clock symbol? This is serial DCE, and the right side is what? Serial DTE. So DTE, DCE cable we have to use between the router to router. Let me use serial DCE cable. Take DCE cable and click on router. See, if we click on router, what is showing here? It's showing auxiliary port, console port, and fast Ethernet port. But it's not showing the serial port. You know why? Because in packet tracer software, by default, serial ports is not available. We need to we need to insert the serial slot, serial ports. How? Click on router, maximize it, and if you zoom in, see the slots are empty here, right? Have you seen the black? So these are the WAN slots. The slots are empty. The WAN cards we need to be insert. From where you can get that? The left side we have modules. So these are the list of slots, list of the ports is there. So in the modules, second last, WIC2T, WAN interface card. So dual serial port WAN interface cards for Cisco. In the right side, the bottom, we have the slot is there, right? This module, we need to be drag it and drop here. So before drag and drop, your router power should be off. You know, here showing the power green color. If your power is not off, if you keep trying to forcefully insert, we'll get another message. Why? So cannot add a module when the power is on. So your power should be off and drag it and drop it here. And power should be on. Go to CLI. Your router is booting up now. Same method in router 2, router 3 also. In router 2, click on router, power off, second loss, WIC2T, drag it, drop, power on, CLI. Minimize, and router 3, power off, drag it, drop here, CLI. So 3 routers we have added WAN ports. Now if you use serial DC cable, click on router. Now showing is what? Serial 000, serial 001, numbers, port numbers is showing. So we can use 00 also, 01 also. As per my example, I'm using serial 000. On other side, we can connect 0 also, can connect 1 also. My example 1. So here 00, here 001. And head office to branch 1. Again, S00, other side S0/1. Okay. So this is R1, this is R2 and R3. R1 to R2, R2 to R3. What is the port number I have connected, guys? Please tell me the port number in R1. S0/0/0. On R2,
S
One.
0
0
slash
slash
0
0
slash
slash
0
1.
1
R2 to R3 between here.
S 0 slash 0
0
slash 0.
0
0/0.
R3.
S1.
0 slash 0 slash 1
Yeah. So I request to everyone how I am how I'm doing the same thing you also do when you're practicing. So don't directly go on the packet tracer you can design. First, how you design the packet tracer, the same thing you can make in your documentation also. Paperwork. Draw the diagram in your paper and write the numbers. Otherwise you'll be confused. Okay? Right. Now as per routing, as per condition, IP condition, R1 S00 IP address, R2 S001 IP address, both should be in same network. So my example, 172.16.0.1, in other end, 170.16.0.2. Again, the same logic. R2 S0, R3 S0, both should be in same network. So 172.17.0.1 I'm using. Here 172.17.0.2. Okay, yeah, the same. Let me configure on R1. So first I'm configuring host name of the devices. Config terminal, host name R1, erase router 2. Yeah. Enable config terminal, host name is router 2, last router, host name router 3. So only have configured host name, right? So what is our task now? We have to configure R1 serial 00 IP address, subnet mask, these things, right? Let me configure as 00. Before configuration, first let me check the status of the ports. In privilege mode, show IP interface brief. So this command will give you like all interface in your router brief information. Show IP interface is what? Your LAN interface status, WAN interface, all ports, all interface status we can get now. Enter. Yeah. Fast Ethernet 00, Fast Ethernet 01, serial 00, serial 01, like all interfaces and its status. Status is admin down, protocol down, IP address unassigned. So let me take troubleshooting, configuration along the troubleshooting. So interface, IP address, status. Which one need to focus? Serial 0/0. Serial interface, R1 serial interface 0/0. By default status is Yeah, please. Say this one. Interface is S0/0/0. On S00, IP address is what? Unassigned. IPs are not assigned. So S00 status is what? Admin steadily down.
Admin down.
Protocol is down. Why? Because S00 is not yet configured. Let me configure. In R1 router, configuration mode. Interface serial 0/0/0. IP space address, or example 172.16.0.1 255.255.0.0 class B subnet mask. IP is assigned and no shutdown. No shutdown. So I have assigned IP address and I have entered no shutdown command also. Now once again, if you check the status, show IP interface brief. What is showing here?
IP address and
Yeah.
status
IP
is
address
down.
is IP address assigned. Okay, but status is what?
Down.
Why? We entered IP address and we have entered no shutdown command also, but still is showing down. Why?
Down.
Protocol is down.
Protocol is down.
Protocol.
Layer 2 is
So
down.
not only a protocol, like status is also down.
Other router port is it is down.
Exactly, Pradeep. Right. See, what we understand here, troubleshoot.
Your clock also should be given.
In troubleshoot is, if it is showing admin down, protocol down, then local interface is not configured. So problem with what? A local router interface issue. Is showing not admin down, showing is what? Only down and protocol down. Why? So we have assigned IP address to R1S00 and we have entered no shutdown command in R1S00. But what about your other end? R2S001. What is the default status of S001 of R2?
Shutdown.
Down only.
Shut down. So that is why here it is showing down. If it is a local is down, then shows what? Admin down, protocol down. That is local interface problem. If it's down means what? Remote interface. Remote interface problem, or if it's a cable problem, also same output we can get. Status is down, protocol down. 2 points need to be verification here. Remote interface you have to check and cable you have to check. Let me do one thing. We'll configure remote interface, which is R2S001. Let me take R2 console. Yeah, this is R2. Interface serial 0/0/1. IP address 172.16.0.2. 0.1 for R1, 2 here. 255.255.0.0. No shutdown. So IP is assigned. And no shutdown command also I'm going to enter. No shutdown. Encapsulation point to point. So IP is assigned and no shutdown command is entered. Encapsulation is being configured. Now let me check status once again in R1. In R1, show IP
Interface free.
interface interface brief. So what is showing now status?
Up.
Status is up. Protocol?
That protocol is down.
Why?
Other end also it's down, right? R3, that's why.
Why R3 come in the picture here? Now connectivity is
PPP
done between
R1
R1 to R2 only.
Configure that.
R1 PPP is not configured.
You need to configure the protocols in router.
Exactly. See, in R2 S001, we have configured which protocol? Encapsulation is point-to-point protocol
PPP.
configured. On R1 S00, which protocol?
Point to point should be configured.
Point.
It is not configured.
We're not configured. If we're not configured, which protocol is there by default? Cisco routers.
HDLC.
Cisco routers by default HDLC is there, right?
HDLC.
Yes.
Yes.
So one side is HDLC, other side is point-to-point protocol. Whenever encapsulation is mismatched, then you can get this output.
Down.
Your link is okay, means your link wise is okay, but protocol is down.
Protocol wise down.
Yeah, when encapsulation mismatch. So whenever if we see status is up, protocol down, then what is the troubleshoot is encapsulation, you have to be check both sides. Encapsulation mismatch. Let me do one thing. In R1 also, I'll configure point-to-point protocol. If both sides point-to-point protocol, then the link will be come up. In R1, interface S000, encapsulation point-to-point protocol. See, here message is what? Status. Interface status is up, but interface protocol down. Now if you enter, you will get one notification. See here. Protocol on interface is up. Because already interface is up. Now just now protocol is also up. Okay. Show IP interface brief. So now interface serial 00, IP address is assigned, status is up, and protocol is also is what? Up. Status is up. Status is up means what? Link wise means cable L1. Cable is okay. L1 is okay. Protocol like encapsulation, point-to-point protocol, and HDLC, these are layer 2 protocols. So layer 2 wise is okay. So layer 1, layer 2, everything is what? Fine now. Okay. Up. So R1, R2, WAN link 1 is now upstate. Let me check the communication. From R1 privilege mode, if we use ping to your R2 serial IP address 172.16.16.0.2. You can get success rate is 100%. So link is what? 100% active. It's clear? So like this, we can configure WAN interfaces, configuration, and we can understand troubleshooting point also. Anyone, can you help me out how to configure R2, R3 link? How to make it ease up? Tell me the configurations in R2 first. Yes.
Interface serial
Serial.
S 0/0/0
Okay.
and IP address
Yeah.
172.17.0.1
Okay.
and subnet mask 255.255.00.
Okay.
Press enter.
Yeah.
And no shutdown.
All right. So IP address assigned, no shutdown command is also entered. Now, if we check the
Encapsulate.
status, show IP
Okay. Interface
brief,
brief.
serial 0/0, IP is assigned, status and protocol. Status is down, protocol is down. Problem is what?
Protocol is down.
Problem is what? Status is down, protocol down. Why?
It's in local interface. That's
So status is down,
configured.
protocol down means remote interface problem. Means R3 is
yeah.
not configured. Okay?
R3. Yeah.
Yeah, we'll configure R3 now. Interface serial. R3 serial port number is what? 0001.
0/01.
Yes.
Enter.
IP space
IP
address.
address
Okay.
172.17.0.2.
Okay.
Subnet mask 255.255.00.
Okay.
Enter. And no shutdown. Enter.
Yeah.
End.
A configure encapsulation point to point.
Point to point.
So IP address assigned, no shutdown command, encapsulation we have
Encapsulation
enabled,
assigned.
point to
Yeah.
point protocol also. Now once again, if we check status on R2, show IP interface brief.
Protocol down.
Why? Status is up, protocol down. What is the troubleshoot?
R2 protocol should be
R2 we did
assigned.
not assigned encapsulation PP.
Yes. So status is up, protocol down means problem with what? Encapsulation mismatch.
Mismatch.
So let me configure encapsulation point to point R2 also. Interface serial 0/0 encapsulation point to point.
Encapsulation P point to point.
A link will be up. See one thing here in packet tracer, I'm not showing like in the clock rate how to define how to generate the bandwidth in real time. Okay, I'll show you here also. Where we have to assign the clock rate on DC or DTA.
DCE.
So how we can check serial 0/0 is a DC or DT means we can use command is show
Show controls.
controller serial
Serial
0/0/0.
0/0.
Showing is what here?
DCE.
So it's a DCE means we have to generate the clock.
It will
Config
show
terminal.
bandwidth also, right?
It's maximum supporting bandwidth.
Mm.
Default some bandwidth is there actually. You want to customize, you can do it.
Uh-huh.
Clock rate, clock space, rate space, and if is a question mark here, question mark. Speed, bits per second, minimum and maximum. Choose clock rate from list of above. From the list, you can choose any bandwidth. Example, I'm using 64,000. Now it is generated, 64,000 is generated. Now if you check once again, show controller serial 0/0. What is the clock rate now?
64,000.
Yes. It's generated, right?
Yeah.
R2 S00 is DCE. It means what about R3 S001?
DTE.
It should be DT, right? Yes, of course. Let me check that. Show controllers serial 0/0/1. Are you showing?
DTE.
DTE. So transmission and receiving clocks is detected. Means bandwidth is detected. It's accepting that actually. DC generating is accepting. So like we can configure bandwidth.
Hello, where to show this? Where can I see this protocol status? Protocol type, encapsulation types.
Encapsulation type we can see in show interface serial 0/0/0. Show interface serial 0/0. Enter. Here you can get which encapsulation is enabled. Encapsulation point-to-point protocol is running. Or you can get in show running configuration also. In show running configuration, interface serial 0/0, what IP is assigned, which encapsulation is enabled, and clock rate, see encapsulation PPP. Here I can get show running config. Okay, so today configurations commands I'm sharing on chart. IP address, no shutdown, clock rate, encapsulation. And verification, show IP, interface, brief, or show running config or controllers. Show controllers command also you can use to check whether it is a DC or DTE. Okay. The WAN link 2, ping 172.17.0.2. 100% success rate. So yesterday we have discussed how to assign IP address to fast Ethernet and how to make it is up. And today we have seen WAN technologies, type of WAN technologies, type of WAN topologies, WAN connectivity, what type of equipment we use on muxes and optical fiber cables, and master and slave devices, and point-to-point HDLC configurations, and troubleshoot and verifications. Finally, we make your WAN link is up. LAN interface up, WAN link is up. Why? Why we need to configure LAN interface upstate, and why need to make your WAN interface upstate? What is the main point, guys, here?
Connection between two branches.
Okay. No, technically do we think about it? Now, what is the router functions? Remember router functions, functions of router?
Question, Balu.
Yeah.
What was your question? Can you repeat your question?
My question is why we are making your LAN port is up, and why we are making our WAN link is upstate. Assigning IP address. We are making active state, right, for LAN and WAN interfaces. What is the purpose? That is
Data
my question.
transfer
Between
Forwarding.
Very good. Yes, please repeat, Mr. Anand, sir.
Packet forwarding.
Exactly. So why you are making your LAN port status is up? Your LAN port sending IP traffic to WAN port. What we call this process packet switching.
switching.
And what WAN port will do sending IP traffic to router 2 packet forwarding. So router functioning is what? Packet switching and packet forwarding. So now your router is ready for packet switching and packet forwarding. Router 1 is ready and router 2 is ready for packet switching and packet forwarding. Now we can generate the packets. I mean, you can generate our IP traffic. So what is our final target? R1 data traffic should come to R2 LAN. All branches, LAN to LAN, should be communicated. So LAN traffic has to move from R1 LAN to R2 LAN. I mean, one network to another network. That process is routing process. IP routing need to be enabled, routing types and routing methods and routing conditions. So that we'll discuss next session. Okay. So finally, we have to make sure that your router should be ready for packet switching and packet forwarding. When LAN interface should be upstate and WAN port should be upstate. I mean, interface should be up and protocol also should be up. Then packet switching, packet forwarding is possible. So once all routers links are being up, then we can implement IP routing. If you implement IP routing, then packet will be flow from one network to another network. Communication is enabled. It's clear?
This will happen only when internet is on.
Yes, in real time, if service provider link is okay, then only it's possible.
Okay.
In packet tracer, you're practicing internet is not required.
Okay.
Even in our office also, if you have 2 routers, that is enough.
Enough, yes. Internet is not required. You can practice in your office also if you have 2 routers. All right, so this is all about for today, and tomorrow we'll continue with IP routing. What is IP routing, types of IP routing, conditions of IP routing, and how to implement it. So those things will continue. Thank you. Have a nice day. Thanks to all.
Thanks.
Yeah, thank you.